Everybody. So we're starting section 6.2, and I just want to congratulate everyone on section 6.1. You guys went through that section really nicely. If you guys still having issues, please come on in, get help. We are shifting gears a little bit to the study of parallelograms and shapes that are basically quadrilaterals. The first one that we're looking at is, like I just said, a parallelogram. And so here's the definition. A quadrilateral with two pairs of parallel sides is a parallelogram. Please understand that's the definition. Now, when you write it, the notation, and this isn't heavy on notation, but this is the symbol for a parallelogram, and it has to be in front of the four corners of the parallelogram. Now, notice this as well. You either go this way, clockwise, or counterclockwise. So if we're starting with A, B or D has to come next. Just make sure you remember you go around this way or you go around this way to name the parallelogram. Also notice that the opposite sides in the definition say that they are parallel. So that's going to bring in some old ideas that we had in the past. For example, if you look at these two parallel sides, this is a transversal. These two angles right here and right here are called same side interior angles. And you notice I marked one with one arc mark and the other one with two. It's because they're not congruent necessarily, but they are always supplementary in a parallelogram. Likewise, this angle and this angle would have to be supplementary. You may have noticed also that I happen to put one arc mark here and two arc marks here. We'll talk about that in just a little bit. Couple theorems I want to point out. First one, if a quad is a parallelogram, then its opposite sides are congruent. You may have guessed at that just from the look at it, but this side here and this side, put one tick mark there, two here, and put two there. Opposite sides are definitely going to be congruent. Three more properties that we have. Oh, before I go on, I did want to mention this notation right here. And I encourage you in your meaningful notes to do this. Now, I'm not certain how many students in my class take meaningful notes. I think now's a good section to start if you don't, because there are a lot of theorems and definitions and properties in this section. So if you see something like this, this is how you talk about this. If the quad is a parallelogram, that arrow means then opposite sides are congruent. So let's look at the next one down here. Without reading what it says above, you should be able to say if the quad is a parallelogram, then opposite angles are congruent. Now go back to that start. Do you see why now these are called opposite angles? And these are opposite. Why I marked this with one arc mark and I marked these with two arc marks? That's why, because I knew that was coming. Okay, theorem number 3. If a quad is a parallelogram, then its consecutive angles are supplementary. We already talked about why. The reason its consecutive angles are supplementary is because same side interior angles. Those lines are parallel and same side interior angles. Last one, if a quad is a parallelogram, then its diagonals bisect each other. And I think anytime I use the word bisect, it should raise a warning flag to my students because bisect is historically a tough concept for geometry students to understand. Here's the notation. If the quad is a parallelogram, then its diagonals bisect each other. Okay, so bisect each other in this picture would mean this side, or this part of the diagonal, is congruent to this one because it's been bisected, it's been cut in half. And this segment is congruent to this one because its diagonals have been cut in half. Okay, so that's our beginning theorems and definition. Remember the definition. A quad with two pairs of parallel sides is a parallelogram for this next section 6.2.